Good morning dear students, welcome back. I am your physics professor Dr. Nagraj. So in view of coming examinations and internal tests, I would like to make few videos especially for EEE stream, Applied Physics for Engineering, Electrical and Electronics Allied Branches Engineering stream. So here I start with module 1. Dear students, I just go with questions and answers instead of explaining the whole chapter. The whole chapter videos are already available in my YouTube channel. Please go through, and whichever the topic is not covered on so far, that I will upload very shortly. So this is only model questions or important questions. I don't call it as model questions. Important questions and corresponding answers. Okay. Well, with this I start with module 1. See, module 1 is all about quantum mechanics. It consists of de Broglie hypothesis. This is a syllabus, outline of the syllabus, which includes properties of matter waves, Heisenberg uncertainty principle, non-existence of electron inside the nucleus, wave function, principle of complementarity, and then time independent Schrodinger wave equation, application of this equation to particle in one-dimensional potential well, and calculation of eigenvalues and eigenfunctions. And we expect this much prerequisite from your side. So you should know the wave particle duality, which you already studied in PU. And with this I start with the question number 1. State and explain de Broglie hypothesis. Obtain the expression for the de Broglie wavelength in terms of mass and velocity. See dear students, after watching this video, please go to description box. I have given one link, so using that link you can download the notes. Whatever I explain here, it is available in PDF form. You can download it and you can refer for your further examinations or internal tests or whatever it is. Well, coming back to this particular question, it is all about de Broglie hypothesis. And you know this is de Broglie hypothesis. De Broglie, what he says after the wave particle duality, see when what happened, some theories, some properties of light we can explain only using wave theory, like interference, diffraction, polarization, and some properties like photoelectric effect, black bodies, Compton effect, all these things we can explain using particle nature. So this finally led to the formulation of duality, wave particle dual nature. So all physicists accepted that light behave like a particle as well as wave. So after the success of wave particle duality in 1924, de Broglie came out with this statement. See, according to him, every moving particle, whether it is electron, proton, neutron or atom, molecule, a speck of dust, anything, whenever you call a particle as material particle, it is having certain mass. So whenever a particle is moving, it is associated with a wave, and that wave is known as matter wave, also called as de Broglie wave. So very simple statement. According to de Broglie, whenever, even for example this pen, if it is moving, it is behaving like a wave, and the wave is known as matter wave. And now coming to wavelength. See, whenever you call something as wave, there must be wavelength, and you know what is wavelength? It is the distance between two successive crests, okay, or two successive trough. So you know the sinusoidal pattern of the wave. So that wave looks like this. This is the wave, right? So from here to here, this is the distance, and this is nothing but lambda. So according to this equation, lambda is given by h by p. Okay, so h by p. Now we have to derive this equation from first principles. First principle means what? For particle, what is the expression for energy? For wave, what is the expression for energy? Then you combine them together. See, for particle and for wave, we have energy equation. Einstein's mass energy relation, E equals mc square. Planck's quantum theory, E equals h nu. See, Einstein's theory is about particle behavior. Planck's quantum theory is about wave behavior. E equals mc square, E equals h nu. So just equate them. So when you equate them, mc square equals h nu, and cancel, transfer one c this side, so that mc is equal to h nu by c. Okay. So h nu by c. H nu by c, please observe carefully, c by nu is nothing but wavelength. Here we have nu by c. Okay, this is a first PUC formula, or even in second PUC also you study this equation, frequency into wavelength is equal to velocity. So that velocity divided by wavelength is equal to frequency, but I have lambda divided by this is frequency. C divided by frequency is equal to lambda, or frequency divided by C is equal to 1 by lambda. So C by frequency is lambda. I have a nu by C, therefore it should be h divided by lambda. Okay, let me proceed with the steps. And MC, this MC is nothing but momentum. Mass into velocity is equal to momentum. I have m into C, therefore P is equal to h by lambda, or lambda is equal to h by P. And for any other particle, this lambda must be h divided by mv, where m is mass of the particle, v is the velocity. So that's what this equation is. Well, this is the derivation of the de Broglie wavelength. With this I move on to the next question. What are matter waves? Okay, so definition. Already I mentioned the definition, but once again, that means questions will appear in different form. Answer may be same, but the question, framing the question may be different. It varies from college to college, or person to person, or with some other question they may club like this. See, for example, here they have clubbed the matter wave definition with the properties of matter wave. What are the matter wave? Give the expression for wavelength of the matter wave in terms of kinetic energy. Outline the characteristics. That means you have to mention the properties of matter wave. Okay, first, matter wave is the wave associated with particle which is in motion, and lambda, that is equal to h divided by root of 2m into kinetic energy. See, there are many equations for de Broglie wavelength. I just mentioned them. Okay, lambda is not only just equal to h by p, is also equal to h by mv. In terms of kinetic energy, we can write h divided by 2m into E, or kinetic energy. Some teachers they write it as E, some teachers they write it as Ek, some teachers they write it as Ke, and then lambda is equal to h divided by root of 2m q into v, where q stands for charge on the particle. Lambda is equal to h divided by root of 3mk into T, where K stands for Boltzmann constant, T is the absolute temperature. So like this we have many equations for lambda in terms of different parameters. Well, coming to the properties, just I will erase all those steps so that you can see them properly. I just erase this. Okay, now let me read the properties of matter waves. First of all, it is not a mechanical wave, not a non-mechanical wave, because it is something like a wave associated with the particle. Therefore, I cannot call it as a mechanical wave or non-mechanical wave. So matter waves are produced by moving particles, hence they are neither electromagnetic, means non-mechanical, nor acoustic, means sound waves. Sound waves taranu alla, light waves taranu alla, they are totally different. They can travel in vacuum. Presence or absence of material medium does not affect their behavior. So this is what I told. Medium, whether it is there or not, matter waves will not mind it at all. Next, matter wave is associated with periodic variable called wave function. So in a matter wave we have a variable called wave function. It is represented by x and t, and it is the probability of finding the particle at a given place and at a given position. Next, amplitude of the matter wave in a particular region represents the maximum probability. Just let me just mention this. See, wave looks like this. This is a wave, for example, like this. In case of normal wave, we call this height as amplitude. It is nothing but maximum displacement. This is in case of normal wave. But in case of matter wave, this is nothing but maximum probability of finding the particle. See, after all, we are talking about a particle which is continuously moving. So at a given place, what is the probability of locating the particle? For example, you are in your college right now. Right now means, let us say, 9 to 10. So if I try to locate you in your house, the probability is 0. Like that, probability of finding you in the college is maximum, in your house is 0. So this way probability keeps on changing with respect to position as well as with respect to time. That is given by this parameter called wave function. Next one, the amplitude of matter wave in a particular region is representing what? is representing the maximum probability. That's what I told you. Next, matter waves are associated with two velocities, namely phase velocity and group velocity. Phase velocity is greater than speed of light. This is very important. Normally we expect this property. Matter waves ಗೆ ಎರಡು ವೆಲಾಸಿಟಿ ಇರುತ್ತೆ, ಒಂದು ಗ್ರೂಪ್ ವೆಲಾಸಿಟಿ, ಇನ್ನೊಂದು ಫೇಸ್ ವೆಲಾಸಿಟಿ. There are two velocities for matter wave. One is group velocity, another one is phase velocity. For all the waves there is only one velocity, whether it is a sound wave, light wave or any wave, there is only one velocity. For example, sound, it travels with a velocity of 330 meter per second. Light, it travels with a velocity of 3 into 10 power 8 meter per second in a given medium. Medium to medium it will change, but in a given medium it is only one velocity. But for matter wave there are two velocities, namely phase velocity and group velocity. So since phase velocity is greater than speed of light, that we can prove, but it is not included in the syllabus. Just only mention phase velocity value is greater than speed of light, therefore we don't consider it. See, anything which is greater than speed of light do not carry any meaning, we cannot explain it, so we simply ignore. Therefore we consider only group velocity. So mention this point without fail. Matter waves are associated with two velocities, phase velocity, group velocity. So we ignore phase velocity because it is greater than speed of light. And finally, see, matter waves are called guiding waves. Yake antandre, why we call them as guiding waves? Because they guide us, they monitor us, they help us to monitor the particle, to understand the particle, to know about the particle, like particle's position, momentum, kinetic energy, spin, charge, etc. We can determine with the help of wave nature. Especially when it comes to subatomic world, quantum world, particles will not reveal their details at all. They will not reveal their details at all if you treat them as particles. If you treat them as waves, definitely they will tell everything about anything about them, everything and anything about them. So if for example I want to know charge on the electron, I must treat electron as a wave. I want to know spin of the electron, I must treat the electron as a wave. That's why I said matter waves are guiding waves. They help us to understand the particles behavior. So these are the properties of matter waves. Coming to next question. Define the terms phase velocity and group velocity. Discuss the importance of wave group. Write an explanatory note on the principle of complementarity. So club madidare illi. We have to define phase velocity, group velocity, and then importance of the wave group. From the wave group we have to give the definition of principle of complementarity. Let me go ahead. First of all, I told you, whenever a wave is traveling, it is having some velocity. For example, sound, it travels with 330 meter per second. Light, it travels with 3 into 10 power 8 meter per second. Look at this diagram. I just show you the write the diagram. This is a wave propagating in this direction. So particles here they go upward, whereas particles here are going downward. So this is possible only if the wave is traveling with this velocity, and this velocity is maintaining the phase of these particles, let us say 1, 3, 5 constant, similarly 2, 4, 6 constant. So in order to maintain the phase constant, that wave has to travel with this velocity. That's why I call this as a phase velocity, and it is possible only in the isotropic medium. What is isotropic medium? A medium where everything like temperature, pressure, refractive index, optical density, everything is constant. Then we call it as isotropic medium. Now comes the definition. The velocity with which the wave is propagating in an isotropic medium is known as phase velocity, and it is given by V is equal to omega by k. So I hope you followed this definition. Now just I erase this. I go to the next definition. Next definition is group velocity. A wave group is formed. First of all, let me tell you how the wave group is formed. Suppose if you have two waves of different wavelength, this is one wave, this is another wave. Look at the wavelength difference. The result will be not a single wave, but it is a wave of variable amplitude. This type of group is formed. In this case, amplitude is periodically changing. Look at the amplitude variation. It is increasing and then decreasing. This blue line represents amplitude variation, and it is increasing and decreasing. So here look at this portion, it is a group of waves. This group is proceeding in a medium with certain velocity, that is called group velocity. So a wave group is formed in a anisotropic medium. It normally happens in anisotropic medium. A wave group is formed when two or more waves of slightly different wavelength superimpose. That's what I told you, no? When two or more waves of different wavelength superimpose, a wave group is formed. As a result, that group keeps on moving in a given medium, and that velocity of that whole group is called as group velocity, and certainly it is not omega by k, it is d omega by dk. So why it is not omega by k? Because I said wavelength is changing, frequency is changing. So omega represents frequency, k represents wavelength. You know, omega is equal to 2 pi f, and k is equal to, okay, omega you know is equal to 2 pi f. Just I write omega value. Omega is equal to 2 pi f. K is equal to 2 pi by lambda. So omega is changing, therefore it is d omega. K is changing, therefore dk. So this is group velocity. Now let me proceed with the significance of wave group. See, wave group, okay, I just read and then I will explain. Wave group of matter waves represents particle motion. It is a representative of moving particle. Particle can be located anywhere within the group at a given time. Okay, see, it is like this. Suppose if you consider particle as a particle, then you can locate the position of the particle just by dot. You can mention the particle position by dot. If the particle is a particle, then its position is well defined like this, But here we are not treating particle as a particle, therefore its position can be located anywhere from here to here. In this region it can be located. Here the probability may be less, here the probability may be slightly more, here may be more. See, okay, let me write like this, anywhere from here to here. So here it may be slightly less, maybe slightly more, slightly less, like that. So probability keeps on changing like this. So these probabilities are going to represent, okay, they produce a group this way. Andre one particle anna for example, if pen ide, where is pen andre, you can show it is here. But if the pen is replaced by electron, and if I ask where is electron, you cannot say electron is exactly here. It can be anywhere from here to here. That means the position is spread over certain area, certain distance, certain volume. So in that volume, the probability of finding the particle keeps on changing. When you draw the curve, it represents or it resembles the wave group. So therefore I said wave group is a representative of the particle. Some teachers they call wave group as soul of the particle. Wave group is a representative of particle. In the particle we never treat as a particle, we never treat as a single wave, we treat it as a group of wave. If the group is very small, then position is more accurate. If the group is too big, position is not accurate. Like for example, you have a rat. You allow the rat to sit in a box of 1 feet width, 1 feet length, and you keep the same rat in a box of 1 meter width. Okay, now you try to catch a rat in both the cases. Definitely in the smaller box, that means 1 feet by 1 feet, your probability of catching the rat will be more. That means the position is more accurate. Whereas here in 1 meter by 1 meter, position measurement is not accurate. So this way wave group will tell you, the size of the wave group will tell you the probability or uncertainty or error or accuracy in the measurement of the position. If the group is small, position is accurate. On the other hand, if the group is big, please follow carefully, position is not accurate, but its momentum can be measured accurately. So what I mean to say, for smaller groups, definitely particle is no more a particle, it won't be at a single place. Like one marble tara, a pen tara, one duster tara, one chalk piece tara, one jagadalli irodilla. Let us say this is a particle. Can you see this small chalk piece? Okay, if you treat this as an electron, it is definitely not here. It can be anywhere between these two fingers. It can be anywhere between these two fingers. The gap between the two fingers tells you the width of the group. As the width of the group reduces, increases, error in the position decreases, position become more accurate. Conversely, if the gap increases, momentum becomes more accurate. This is the significance of the wave group. So look at the diagram. There are two wave groups mentioned here. Figure 1 represents smaller wave group. Smaller wave group means more accuracy in the position. Bigger wave group means more accuracy in the momentum. So if you look at this explanation, the significance of wave group, what comes to our mind? At a time we can have only one parameter more accurately, another parameter definitely there will be some error. If you focus on the particle parameter, you lose information on the position parameter, momentum parameter or wave parameter. So this is what is called principle of complementarity. ಒಂದ್ರ ಕಡೆ ಗಮನ ಕೊಟ್ರೆ ಇನ್ನೊಂದು ಮಿಸ್ ಆಗೋ ಚಾನ್ಸ್ ಇದೆ. ಒಂದನ್ನ ಇನ್ನೊಂದನ್ನ at a time you cannot measure both ಅನ್ನೋದೇ complementarity. This was modified by Heisenberg, which we call as Heisenberg uncertainty principle. See, look at the complementarity principle. When importance is given to the particle nature, its wave nature is suppressed and vice versa. The inability to observe the wave nature and particle nature of matter simultaneously is known as complementarity principle. Actually, this principle was proposed by Niels Bohr and it was modified by Heisenberg. I hope you followed. See, if you focus on particle, wave nature is suppressed and vice versa. So this is principle of complementarity. I hope you followed this, and definitely see, they will not ask you to derive the wave group or group velocity expression, phase velocity expression. It is not there in the syllabus, only mentioning the expression. Well, with this I move on to the next question. Now comes the most important concept in the quantum mechanics, one of the fundamental principle called Heisenberg uncertainty principle. State and explain uncertainty principle, give the significance. Show that electron emitted during beta decay does not exist inside the nucleus using this uncertainty principle. This is one of the frequently appearing question. Uncertainty principle is very useful. Using this we can show that electron never exists inside the nucleus. I will go ahead. First of all, statement. In the simultaneous measurement of both position and momentum, I told you complementarity, if you focus on position, momentum is suppressed and vice versa. If you try both at a time, definitely there will be some error. So that's what he says, there will be some error. In the simultaneous measurement of both position and momentum, there is always some error. The product of error in the position and momentum is greater than or equal to h by 4 pi. So this is one statement, and mathematically it is given by delta x delta p, where delta x is uncertainty in the position, means error in the position, delta p is error in the momentum, is greater than or equal to h by 4 pi. See, uncertainty principle not only we can express in terms of position momentum, also in terms of energy and time. We know electrons or any atoms, they always stay in the ground state normally. When excited, they go to higher level. Higher level means which one? This one. We know this is the higher level. But according to uncertainty principle, it may not go exactly to this always. It may go slightly above, slightly below that also. That difference is known as delta E. And we know electrons, they stay in the higher level for 10 to the power of minus 8 second. It may not be minus 8 second. Sometimes it may be slightly more than 10 power minus 8. Sometimes it may be slightly less than 10 power minus 8 also. So that difference is delta T. So uncertainty principle says delta E into delta T is greater than or equal to h by 4 pi. What is the significance? Statement over, explanation over. Explanation means writing these two equations and mentioning what is delta x, delta p, delta E, delta T. That's all. Now next is significance. Very important and very simple significance. See, in quantum world, in subatomic world, no measurements are accurate. All the measurements are probabilistic. What does it mean? For example, this pen. What is the length of the pen? If I ask, what you will do? You take the scale and measure. Sir, it is 10 centimeter. Or what is the mass of this pen? You will take weighing balance and then you measure it and you tell me that its mass is 100 gram. what is time now? 9 o'clock or 9:20, like that. You never say, sir, length is probably 10 centimeter, mass is about 100 gram, time is around. No uncertain in your measurements. As long as your measurement is perfect, as long as your instrument is perfect, your measurement answers are also accurate. But in quantum world it is not so. What is the distance between nucleus and electron? Means what is the radius of the orbit? I cannot say it is 0.58 angstrom. It is probably 0.58, or the most probabilistic value is 0.58 angstrom, like that. So all measurements are probabilistic, no measurement is accurate. This is the essence or significance of Heisenberg uncertainty principle. One line significance, that's all. Physical significance of uncertainty principle is that in subatomic world, measurements are not exact. No measurements are exact. All the measurements are probabilistic. With this, now let us take up one important application, non-existence of electron inside the nucleus. First of all, we know inside the nucleus there are only protons and neutrons, no electrons, and the nucleus radius is r is equal to r naught into a to the power of 1 by 3, where r naught is a constant, a is mass number. No electrons are existing. First I assume that electrons are existing inside the nucleus, then I will do some calculation, I will get some answer. If the answer is not matching with the experimental value, then my assumption is wrong. I cannot blame the experiment because experiments are ultimate. Okay, let us make the assumption that electron exists inside the nucleus. For an electron to exist inside the nucleus, uncertainty in the position delta x must not exceed the radius of nucleus. That means if at all it is inside the nucleus, it must stay inside the nucleus, anywhere inside the nucleus. Let us say this is nucleus. Okay, so from here to here, or from here to here, or from here to here, anywhere it can exist. So now you take the difference between the starting point and the end point, it is r only. That means delta x cannot be greater than, so it is always less than or equal to r, and r is already calculated here, that is 10 into 10 to the power of minus 15. Okay, so now let us proceed further. That is delta x, that's what I told you, delta x greater than or equal to 10 into 10 power minus 15. Now, we know uncertainty principle, delta x delta p greater than or equal to h by 4 pi. So delta p equals greater than or equal to h by 4 pi into delta x. Now what you have to do, substitute for h, pi and delta x. H is known, Planck's constant, pi is known 3.14, and delta x is already known. Substitute and calculate, you will get the momentum value of 0.5 into 10 power minus 20. See, when delta x is less than or equal to, then delta p will be greater than or equal to. That means when delta x is minimum, delta p is maximum, and delta p is minimum, delta x is maximum. Well, I have one of the momentum values 0.5 into 10 power minus 20. This is one of the momentum value. Now I have an equation for kinetic energy, that is E equals p square by 2m. Substitute for p and m is mass of the electron, and you will get the answer in joule. See dear students, if time permits, you do the calculation in the exam, or you can directly write the answer. I suggest you to do the calculation. It will give some impression to the valuer. So you know how to do the calculation, and calculators are allowed. P value is already there, 0.5, and m is known, and 9.1 into 10 power minus 31, and calculate E greater than or equal to 85 MeV. That means if at all electron is inside the nucleus, it must possess minimum, I am stressing this word, minimum energy of 85 MeV. That is one of the requirement for electron to stay in the nucleus. Nucleus na ಒಳಗಡೆ ಕೂರಬೇಕು ಅಂದ್ರೆ ಅದಕ್ಕೆ minimum ಅರ್ಹತೆ ಇದು 85 MeV ಬೇಕೇ ಬೇಕು. Okay, if electron is coming out from the nucleus, then it has to come with minimum of 85 MeV. So if electron is coming out from the nucleus, it should carry its energy of 85 MeV. But experimental results are available. Beta decay is the best example. In PUC you have studied. What is beta decay? It is nothing but emission of electron from the nucleus. Inside the nucleus electron was there? I don't know. Electron is coming from the nucleus. That's what I am thinking. Whether it was there earlier or it is newly born baby. That I want to see. Ashtene. I thought it was there inside. If at all it was there, it should have minimum of 85 MeV. Now let us see what beta decay says. It means for existence of electron inside the nucleus minimum 85 MeV, but electrons emitted from the nucleus during beta decay are having a range energy from 3 to 4 MeV, that's all. See, beta decay is nothing but electrons coming from the nucleus only, but their energy is not 85 as expected by me. They are having only 3 to 4. This clearly shows that my assumption is wrong. What was my assumption? I assumed that electrons are pre-existing inside the nucleus, but my beta decay experiment disproves it. So beta decay experiment shows that electron was not at all existing inside the nucleus. Now the question, then how electrons are coming from the nucleus? How the electrons are coming in the form of beta decay? Answer, at the time of beta decay, one neutron converts into proton. You know, neutron is neutral, proton is positive. In order to balance the charge, one electron is created. Thus created electron is coming out in the form of beta. Of course, one more particle called antineutrino is also created. Like how we can explain beta decay, Andre, it clearly shows that beta particles are not the stream of electrons which were existing earlier. They are just created. Agaste hutti ಹೊರಗಡೆ ಬರ್ತಾ ಇರತಕ್ಕಂತ electrons ಅದು. So this is one of the major application of uncertainty principle. Dear students, so far I explained de Broglie concept and uncertainty principle and application. So I divide this module 1 into 2 parts. In the next video, I will take up Schrodinger wave equation, properties of wave function, and then application of Schrodinger wave equation. So please watch my video and also share my videos and also share your comments. Thank you very much.